So just before we start, just a quick word about my background. Mehran just did a great job summarizing it, but I started in this field in 2016 at Zunum Aero as the first employee at the company before we got funding. So I worked for the company for almost a year before we actually had funding. It was an exciting time, and it was cool to see a hybrid electric airplane, which is what Zunum was designing, a 9-seat hybrid electric airplane. It was cool to see 3 people with an idea turn into a 70-person company over the span of a couple of years. And yeah, so that's where I started and got the bug. Before that, I hadn't even thought about low emissions aircraft or electric aircraft. But after that, I just knew that that is the mission for me. So I got to see at Zunum like the big picture since I started so early. I got to see the space evolve a little bit, and then I worked at magniX after that on the DHC Beaver conversion. There was a Harbor Air in Vancouver flew an all-electric Beaver, de Havilland Beaver, and I was part of that. And then I now work at Aviation, as Mehran said. So I'm coming at this from an aerodynamics engineer who's had a little bit more of perspective because I started earlier in the field, but I'm not an expert. I know that there are going to be people in the audience today that know more about specific topics. This is a very, very broad, like low emissions efforts in the aviation industry. That's a very, very broad topic. So hopefully I'll be able to give you a good overview and answer your questions. And hopefully people in the audience can help me out sometimes. Anyway, so for why are we here? Why am I talking today? So aviation has an issue with emissions, as we all know. I think you guys, again, most of you are pretty well aware that aviation accounts for, some percentage of global carbon emissions, about 3, but actually with contrails, with aviation emissions happening at higher altitudes, 30 to 40,000 feet, there are higher impacts from that. And if the sector grows as it is projected to do, if we do nothing, even with the current improvements that we're seeing in fuel efficiency and operations efficiency, we're still going to end up increasing the global share of aviation emissions. The global emissions share will go up, if we do nothing, to 25% of all emissions by 2050. And there are the various bodies that are looking at this, like policy bodies. The International Civil Aviation Organization is the main one. The ICAO has pledged to make all growth carbon neutral after 2020. So basically, if you look at this plot that I'm showing, it's the gray line basically is what they've targeted to hit, and the member states for ICAO have actually, the flag states have agreed to go beyond that and reduce net carbon emissions by 50% by 2050. So if you look at this plot, basically there's the do nothing line is the black line, and if technologies aren't developed, I mean, even with the minor gains that we can make, you can see that we're not really projected to hit that. So what we really need is a step change. Like, we need serious changes, not 1.5% a year. That's what we're seeing right now in fuel efficiency. So we need real improvements in the technologies. So what are those improvements? I've kind of summarized here some of the key areas and the very broad topics. The first being innovative aircraft configurations and powertrain technology. That's kind of where I am, in electric aircraft, in hybrid, in fuel cell, in cryogenic motors. Those are all things that are areas of research to help revolutionize propulsion for aircraft. So then there's another, like maybe perhaps according to the U.S. Climate Action Plan from 2021, like more promising ways development of sustainable aviation jet fuels. So there's currently, I think, 6 different approved ways, FAA approved ways to manufacture jet fuel that is considered sustainable. These are different sources besides petroleum. And again, I don't know a whole lot about that particular field, but the idea is that you can reduce the carbon and NOx and other emissions from combustion with these fuels. So that's another big development area. Improvements in already existing technology, we kind of already have touched on that. Materials, aircraft materials, composites, making aircraft lighter, like the 787 is a good showcase of that. Those can have serious impacts, of course, and improved aerodynamics. There's not a whole lot to be gained there, but there's something. And improvements in infrastructure, ground operations at airports are fairly high energy intensive things. And so that's another area that people are looking at. Flight paths, optimizing flight paths for minimizing fuel use, things like that. But so today, I'm just going to talk about innovative aircraft configurations and powertrain technology, because that's the area that I'm most excited about. But just so you know, there's a lot going on in a lot of different ways, and it's not necessarily just about let's like put out some crazy novel technologies. There's also developments to help keep our existing infrastructure and and make small gains that add up. So anyway, so in terms of, so it's the shiny aircraft, right? In terms of what's happening out there, there is so much. Over the last 10 years, the interest in development for alternate propulsion technology has just skyrocketed. So we're in this cusp of an era where, propulsion technology, we had first propeller aircraft, and then the jets came along and completely transformed the sector. And here we are now looking at a new mode of propulsion again, and it's going to do the same thing that jets did. It's going to change the sector, change aviation. Maybe not today or tomorrow, but it's coming. So, for example, a colleague of mine, David Sercombe, who leads development for electric motors at Magniax, told me that maybe in the early 2010s, when he started going to conferences and talking to people about electric motors for aviation, there was like very little. There's not very much being done. There was not much talk about it. He was one of the first people talking about it. And now, when he went by like 2018, last time he'd gone to the Paris show, just by the end of the decade, there was so much more. It just exploded, the interest in what he was talking about, the number of people doing this. So just the 2010 decade, the odds like really took up the interest in electric propulsion. So, okay, so what do we have? We have on one side, in the small aircrafts, the general aviation and eVTOL field, we just have a whole lot of projects that are in development today to be launched and entered into service, either already are flying or will be entering service by 2025 or earlier. Who knows? A lot of companies have said they'd be here by 2020, then 21, then 23, so it's sliding a little bit, but, different companies are making a lot of progress there. So, for example, there's the Pipistrel Velis Electro. That's like the first aircraft you're seeing here. That's already certified by EASA as an electric trainer. Then there's, I'm not going to go through every single one of these, but so on the left here, you got the NASA X-57 Maxwell, which is a Technim aircraft conversion to you can see like the distributed electric propulsors on the wings. That's fully electric. And I will say, as someone who who in the development of aircraft of a similar size, those papers that NASA has put out about that particular aircraft have been extremely useful. So it's awesome to see NASA doing that kind of research, because we're benefiting so much from their battery reports and thermal, all of like all their experiments and experience there. And then the other thing you're seeing on the smaller side of things is eVTOLs. So I'm sure you guys have heard about urban air mobility. The thought is vertical takeoff and landing aircraft that are either autonomous or remotely piloted, or there's one pilot in there. But the thought is you've got this congested urban space and you want to get from one side to the other. These things can take you at a fraction of the time. And they're all electric, they're quieter. So there are these, it's just that whole sector, the urban air mobility and vertical takeoff and landing aircraft has exploded just in the last 5 years. You've seen company after company come out with a plan to build one of these. And I think there are over 250 projects in that space, with maybe 20 real serious contenders. Yeah, I can talk about urban air mobility for a long time, but urban air mobility is a good indicator of how excited people are to have this form of transportation that adopts electric or low emission technology. And most of those are all battery electric concepts, but there are a couple that are looking at, for example, hydrogen fuel cells. So that is an interesting space. And so from then you have a much smaller number of regional and BizJet projects. I'd say maybe there's, I don't know, maybe 20 projects that I've seen or heard about in the regional category that we're talking like mostly from 9-seat to 20-seat aircraft. These would all be still Part 23 aircraft certifications, and they're a little bit further out on the timeline in terms of development than the GA and eVTOL. And you can see the top aircraft in that category is Eviation. That's where I work, the Aviation Alice. I'll talk about that a little bit later. And so these aircraft, their current range, I should say the GA and eVTOL, those are shorter range, like we're talking 200 miles roughly is their range. Whereas the regional BizJet, that's like closer to 1,000 miles is the end of what we're projecting there. And these are all concepts that are either all electric with batteries, or you got some ideas for hydrogen fuel cell demonstrators there that could turn into real designs. But so the Aviation Alice, where I work, is an all electric. Then you got the Hard Aerospace, again all electric battery, and then the Faradair, the M1H, which is right below that. It's a hybrid electric aircraft, and then the Ampere below that is hybrid as well. So the hybrid ones obviously do have an advantage in terms of range, I would say. But and we'll talk about batteries again. I know that's like the first thing that comes to people's minds when I say 1,000 miles. Everyone's like, that's never gonna happen. We're aviation, aerospace engineers are a bunch that like to keep it real. So I hear a lot of, well, will the batteries ever get there? And we can talk a little bit more about that later. But then, so realistically, these smaller aircraft are gonna be more viable in the shorter term, but the commercial transport, the concepts and development that are needed for that to actually happen, for a twin aisle aircraft to be flying, I think everyone can agree that that's much more in the future, and that's where maybe sustainable aviation fuels can help make a bigger impact in the shorter term in the next couple decades while we develop other avenues. But there is like development happening there as well, in terms of different novel concepts, There's most of the current thinking there is that batteries are not going to be viable for very large, because, you know, battery energy density is too low. You would need millions of pounds of batteries on a plane like that A380 on the bottom right there. So realistically, another option is hydrogen fuel cell, or direct hydrogen combustion. That's actually what that A380 is supposed to be a demonstrator for an Airbus Zero E program. So there's that. There's turbo electric schemes. There's more concepts that, like, I can show you photos of later, but like the D8 double bubble or the Stark Able ingestion, BLI ingestion, different aircraft improvements that are probably more likely to reduce emissions than just direct, straight up electric battery electric schemes. But so there's definitely research in that area, and that middle photo is actually from Universal Hydrogen. They're doing a demonstrator. Sorry, that's their first Iron Bird, which is Iron Bird is a term for a powertrain that's on the ground that's being tested for use generally in aircraft. And so you can see that they're putting together this demonstrator. One of their next steps is to put their hydrogen fuel cell onto an ATR 72, and so that would be pretty exciting to see a larger 70 to 90 person regional aircraft, and I'll tell you why. And so sorry, I'm showing you the green here is the Velis. It's already flying today. So this is just showing that aircraft like this can happen today. The green are already flying. So the Velis has already flown and got certification. The yellow, that's Joby and EHang, one of like 20. Like I said, there's Lilium, there's all these other companies. They are currently flying. They've already had their first flights. They're in the process of certification, basically. And then we have the Alice and the X-57, which are both supposed to have their first flight this year. So, okay. So like I said, I'm more, my experience has been with the regional aircraft. The Eviation, Zunum, and Hart are all in that space. And so I've seen a lot of doubt about why that is an important field, because it's such a smaller percentage of the the aviation emissions. But actually, that's not really true. If you look at passenger mile share of CO2 emissions, basically, which I think is just correlated to fuel use statistics from FAA, you can see that the largest section, the largest amount of fuel, like the greatest number of passenger miles flown is in the stage length of 1,000 miles or less. That's about 40% of emissions in aviations are from flights from 1,000 miles or less. So if you can make a dent in that, that is a big deal. And so there's a lot, like I said, like the National Academy of Sciences released a paper in 2016 that's like highlighting how that's not where we need to be focusing our research efforts and development. But on it, like realistically, that's a strong strong piece of the pie. And it's a piece of the pie that we can address almost today. You know, we like with battery energy densities at where they are today at 250 watt hours per kilogram, maybe we can't do the full 1,000-mile flight. But as batteries do increase in battery energy density, which they are projected to do, and it's an industry with billions of dollars of research thanks to electric vehicles on the ground, as they get more reliable, as they get more energy dense and safer, we would like to meet them there. So the development kind of needs to happen now so that we're ready to take advantage of that in the next 5 to 6 years when we will see the energy densities go up. So as you can see, yeah, so the majority of emissions happen in that 1,000-mile range or less. And so this market, not only that, but regional aircraft will open up a market, which I'll talk about in a second, which could increase travel in that regional space. eVTOL is a good example of that. A lot of the urban air mobility movement takes passengers that would be moving on the ground and puts them in the air. So if we're using electric aircraft to do that, that's going to be a reduction in emissions. So the other thing about regional aircraft that I'm excited about is that this is a good test bed. The Part 23 aircraft regulations are less stringent than Part 25. It's a good space for us to be pushing the boundaries and working with FAA for certification, so that we can develop these powertrains that can then be hopefully scaled up in the future. So I'll make this one brief. The all-electric airplane movement is not based on the fact that it's got low emissions. So I know that's what we're excited about, but what the people funding this movement are generally excited about is the market transforming opportunity that we have here. In terms of costs, you've got maybe 50% reductions on maintenance and even more on energy, depending on what you're using as your source. So for all electric aircraft, that's probably like 50 to 70%. Again, also I'm not going to give you a single number because it highly depends on the range you're going and how many people are on board and all of this, but there are significant reductions to cost. And that reduction in operating cost is going to mean that routes that were not available before because there wasn't enough traffic on them could open up now. And especially at the smaller, like Alice-sized airplanes, now we can operate in and out of these airports like Arlington, where the Eviation is based, that don't have commercial flights out of them. And so I can fly from here to Moses Lake, on a commercial scheduled flight that doesn't exist today because there's no operator who would do that flight because it's too costly. For example, in 2020, the E-Caravan flew out of Moses Lake, an all-electric conversion test bed for Magniacs and Aerotech. That was a partnership. And when it did its 30-minute flight, it spent $6 on electricity. And that was the operating cost of that flight. Whereas it was a 30-minute flight, it would have taken about $300 worth of Jet A to do that flight. So it's a pretty staggering reduction in cost. So that's one thing. The other thing that, personally, I think is very cool about electric motors is that they have a lot fewer moving parts than the turboshaft engine and an electric motor compared to a jet, turbofan engine is even better. So while there are, some currently issues to be worked through, eventually we're going to end up with electric motors that are just in many ways superior to combustion engines. In terms of maintenance, they can react fast instantly. They have instant torque capability, which is very cool. When you're, if you have an engine failure, you can boost the other one beyond max takeoff power for short periods of time, which is an important capability for safety. And as you go up in altitude, there's no degradation of performance, so you don't have to so you don't have to worry about that. You do still have obviously propulsive efficiency drops, but these are just some of the advantages of an electric motor. The other thing is noise reduction. I think everyone's heard about this with electric airplanes. At takeoff, for example, that that airplane you're seeing on the right is the eBeaver, the one that I helped with the aircraft integration for. I'm somewhere in that photo in the background. That airplane, they recorded at takeoff had 20 decibels lower than a regular DHC beaver, which I don't know if any of you have heard of beaver. I know that sounds like that you're like, of course, beavers are the loudest thing imaginable. I don't know if you've ever been at Lake Union and heard one taking off. They're very, very loud, but that 20 decibel level, that's about what they saw with the Grand Caravan electric conversion as well. So that's about 100 times lower in noise than an existing beaver. So that's pretty exciting. And when you're there, you can hear it. Of course, there's that high pitch sound that you hear with electric motors. But as soon as it gets, 100 feet, 200 feet up in the air, you can't hear it really at all, which is amazing. And then, of course, last and least, low emissions. That's the other advantage, the one that's most exciting to those of us who are working in this field. So in terms of challenges, I'm not going to gloss over it. There's a lot in this field, or in low emission aircraft, to be solved between now and 2035, or in the next decade. If you're looking at all electric aircraft, batteries suck. That's just a truth that we've all accepted, those of us who are working with all electric aircraft. They just have poor cycle life and degradation. So after 1,000 cycles, you're looking at an aircraft that has maybe 80 to 90% of the state of charge capacity that it used to have. That's one thing. Their energy density is low. It's very true that they're currently at 250 watt hours per kilogram, but that is something that is going to change. Like, it has already gone up, I think, over doubled in electric energy density since 2010 of batteries, and we're looking probably in the next few years, we're looking at going from 250 to 400 watt hours per kilogram, or 500, which would really put all electric batteries at a competitive range. We're talking like 500-600 miles, maybe more, depending on what the scheme is. If it's hybrid electric, you could certainly do longer flights with that. So batteries are improving at maybe not the rate they need to for a narrow body aircraft, or definitely not a twin aisle aircraft, to be able to do transcontinental flights. But will they be able to get us to 1,000 miles on maybe 50-person regional props, turboprops type aircraft? Yes. Yeah, I think that's where we're going. That's really going to be the key market for all battery aircraft. The other issues with batteries are that batteries are like people. They like to be at a certain temperature. They don't like to be over 75 or under 45. And their efficiency then greatly varies with temperature and discharge rate. So if you're at really high power, they heat up quickly and lose their efficiency. A lot of things can hurt a battery. Like if you're over 80% state of charge, you're most likely damaging, going to impact your cycle life. So we have to try to keep them at between 20 to 80% state of charge. So in terms of maximizing the level of energy on board, they're very difficult to deal with. But these are all good areas for research, for what kind of battery management system and architecture can you come up with to maximize the energy, usable energy. So that's one thing. For hydrogen, it's another thing. So hydrogen actually addresses a lot of the issues with batteries in terms of range and better like energy density, because hydrogen is in fact more energy dense than fuel, than Jet A. However, then it comes with its own set of challenges in terms of, for example, hydrogen storage and how heavy it is and how volumetrically like large it can be. It's not very dense volumetrically. It's very light, but it takes a lot of space on the aircraft. So putting hydrogen on board an aircraft that's, again, 300 to 600 people going 3,000 nautical miles, there are going to be a lot of challenges in terms of where do you store all that hydrogen, what kind of tanks you use. And when you get to your destination, how do you get more hydrogen? There's a lot of infrastructure issues right now that would have to be dealt with, which are also plaguing the EV fuel cell technology. So those are some of the different issues that are all things that people are betting on being able to solve. So in terms of, you have more than one company. There's ZeroAvia, there's Universal Hydrogen. These are both companies that are currently starting to build demonstrators at the Part 23 level and regional level. So actually, ZeroAvia has already flown a couple of aircraft with fuel cell technology, with a hydrogen powertrain. And I think some of the other, these are all things that they're working through, issues. Like, for example, fuel cells are currently, there aren't very many that have been tested with high power that could be applied to aviation, because they're just not powerful. I mean, their power density is not high enough. They're just too heavy. And so that's an issue. But right now we're at maybe looking at 1 kilowatts per kilogram. By 2024, we're looking at potentially 4 quadrupling that. So there's research being done in these fields to improve and solve a lot of the problems. And then one thing that all of these hybrid, hydrogen, and battery aircraft have in common is their certification challenges. So there is a lot of work being done in the standards, especially on the Part 23 level, to address electric motors and electric aircrafts. But there's not really been a single, there hasn't been a single electric aircraft that has completed certification in the United States as of now. Pipistrel is certified by EASA, and from what I hear, there are years before they'll be certified here. But the industry players like Joby and Zunum, when I was there, and Eviation were all involved in those committees that are setting the standards for certification. And yes, it's a challenge, and it's going to take longer. So I mean, anyone who says they're going to be done and certified in a year, they're crazy. But I think over the next 5 to 10 years, you're going to see electric aircraft that are certified, and for example, some VTOL aircraft that will be certified by 2025, or at least that's what they're saying. So we'll see. And then to address another issue that I know a lot of you think about, yes, a lot of these technologies, like the batteries, there is a well-to-wake issue, right? So for hydrogen, yes, it's a very clean technology once it's up in the air. But if you're sourcing your hydrogen from gas combustion, then that's what we call gray hydrogen. It's not as clean as you might think. And yes, right now there's just not enough infrastructure to source everything from renewable energy. That's true for batteries too, right? There's a life cycle cost to creating new batteries, but we can address that with recycling, improving our recycling, and honestly, for hydrogen, it's just we're going to have to find to increase generation of hydrogen with renewable energies. And that's true. For charging batteries, you're going to have to increase the share of renewable energies. Luckily, in Washington State, we're at maybe our grid is one of the cleanest in the United States at maybe 70% renewable, maybe higher at this point. And by 2050, I think the goal is to be at 100% in Washington. So that's what we're looking for. The fact that electric aircraft or electric vehicles can't today be fully supplied with renewable energy doesn't mean that's not the goal. And so I've never understood how anyone can use that as oh, well, look, they're not fully clean either. Yes, like that's the only way we'll ever get there. So that's why it's important to develop these technologies now. Yeah, so there's I guess the whole point of this slide is to acknowledge that there's a lot of challenges, and I can talk about them all day, but there's also a lot of work being done to overcome those challenges. And a lot of people, believe that that can be done in the next couple of decades, which is better than never, is what I think. So I know this is one of the things we, like in JCATI, we're interested in is the different research areas that could help. I guess to just speak to my experience with this, the biggest areas are obviously battery chemistry research and packing. Right now, we can make a huge dent in the weight of the batteries if we just could package them more efficiently. This is just companies that are doing this right now as best that they can, but there isn't a lot of research in creating battery packs for aerospace. So that's an area. Cell chemistry, rapid charging infrastructure, those are all areas. And for another one that's really big is thermal aircraft, just like a full cohesive aircraft thermal management architecture. That would be incredibly useful. I can tell you for sure that it's really difficult to find thermal people, thermal engineers for aircraft, especially for who have experience in electric aircraft. But you've got either a fuel cell on board that needs cooling, or you've got batteries that need cooling and heating. You've got a motor that's giving off waste heat, and then you've got people that need to be warmed up at 10,000 feet or plus. So how can you use the heat from one to help with the other, or aircraft wing icing, or de-icing? So there's all these kinds of different heat sources and sinks on the aircraft, and how can you unify them for an electric aircraft? It's definitely a big area that needs more research and more attention. And then electrical, I can't really speak to this very much, but there's as you go to higher voltage, how are you gonna have improvements in lightweight? Right now, like battery cables, the power cables on the Alice and other electric aircraft are massive and extremely heavy. So how can we make a dent in that and other components that could seriously help with the aircraft weight and efficiency? And then finally, there are some systems challenges. For example, fuel storage optimization on board aircraft. There's some research in that area right now, and then and systems that are specifically designed for aircraft. For example, electric actuators are. I can talk about that for like 10 minutes. That actually, like for the tail of the Alice, we have the elevators have these actuators that are all electric, right? And most aircraft that are larger have hydraulic actuators, but since we have an all-electric system, we're using electric actuators, and there's no real way to make them dual redundant, because if one fails, it stays it keeps the elevator surface in the same place, whereas a hydraulic actuator would disconnect and the surface can be free moving. And so that's something that hasn't been developed yet. So it's an area that could use some attention. Anyway, so there's a lot, because this is basically all these technologies, the propulsive technology and creating an aircraft from the ground up to work with that propulsive technology, like all electric or hydrogen. These are all like new things, new concepts, and it's kind of like the Wild West right now and when it comes to this area. So it's an exciting place to be, and there's a lot that can be done. And I think if I went back and did it all over again, I would definitely learn more about the batteries or thermal, and because that's really where like the really interesting things are happening. Anyway, so this is I just want to show you, since I have a personal connection to this plane, this is the Eviation Alice. She's a 9-seat, about 7,000 to 8,000 kilograms, depending on who you ask. This is our first flight demonstrator aircraft. And we're currently actually, so we've built the prototype and we'll be flying this later this year. But meanwhile, we're working on the cert type, like the production aircrafts. It's amazing how quickly things change from what you're flying to what you think you'll fly in the next round. But so this is Governor Jay Inslee. He came a few months ago, and I got to tell him about the wing, the innovative laminar flow of our wings, and basically it was great to see interest from the government in what we're doing. And this is like the lamest little video, but it's the first the taxi of the Alice. Basically, the first day we were able to get the aircraft on the runway, so it is kind of exciting. Since then, we've done a lot of ground testing, and we've gotten much more efficient. It used to take like several hours before we could move the aircraft, and now the aircraft is ready before the engineers are in the telemetry room. So it's been a good journey, and I think that's kind of sums up the state of the low emissions industry. It's been a journey. We're learning a lot, and thank you guys for listening.